if you could tell us what are your views on the route to carbon zero?
Yeah, that's a great question, of course. Well, climate change is, of course, the driving factor, and legislation will play a key role in driving lower emissions. Here in the UK, the government has an ambitious target of cutting emissions by 68% of 1990 levels by 2030, reducing to 78% by 2035. Now, whether or not these targets will be met, the first of which is less than 10 years away, the message is clear. And aside from climate change, the health benefits of cleaner air, particularly in urban areas, are well known. The economic benefits of drastically reducing CO2 and particle emissions, leading to health issues and lower life expectancy, cannot be ignored. Governments recognise this, and legislation is playing a key role in driving the technology forward. In Canada, for example, primarily for health reasons, mining companies are moving towards internal combustion engine-free mines, thus removing engine emissions from inside the mines. Eliminating fumes lowers the ventilation requirements, and that brings energy savings, improving the efficiency of the mine. Other benefits of electrification of off-road machinery include noise reduction and greater efficiency, including energy capture through regeneration. Both lead to increased potential non-sociable working hours, leading to increased productivity. People often say, you can't hear an electric vehicle coming, but that is a benefit. Have we become so used to engine noise pollution that we miss it when it's not there? Future generations will not miss the noise or the emissions. Ville will talk some more about the impact on energy.
So, Ville, what are your views?
Carbon Zero has four main segments where we focus on with our customers. Energy production is a segment where currently available the fossil fuels need to be replaced with some alternative renewable fuels. Energy storage and transportation is a segment where liquids and gases and probably solid fuels and the batteries are the way to transfer energy to where it's required. Then the energy consumption is the segment that is probably the most relevant for this conference audience, and how we convert the stored energy to motion in machine. And then the last segment is the energy consumption optimization. And this is mainly to optimize and re-engineer the existing system and processes to be more efficient in factories which already are using electricity as the main energy source.
Thanks, Ville. What are the fundamental changes required in the mobile sector on the journey to carbon zero?
Okay, yeah, that's a good question. Well, transmission power, first and foremost, how do we go about moving the vehicle? Switching from an internal combustion engine powered solution to one which uses electric motors to drive the transmission is, of course, part of the challenge. This might involve individually driving the wheels or powering the drive shaft. Then we have to consider the power steering, for example, which also relied on the ICE in the past. That too will be electrically powered. But moving the vehicle is only part of the equation when we're talking about off-road and in many cases on-road vehicles, which have a requirement for work functions, by which I mean cranes, excavators, backhoes, and many more. In some cases, electromechanical solutions can provide the answer. For example, a screw actuator with a motor can provide a linear solution, but in many cases the implements are powered by hydraulics, and with good reason. I'll let Ville explain a little more about this.
Thanks, Tim. Ville, if you could add on to this.
Yes, certainly. So the power density of hydraulics is something what the electrical actuators can't replace. An example is a power-assisted steering in a mobile machinery. Smaller vehicles can have fully electric assisted power steering, but heavier machines, they will rely on higher power density of the hydraulics. Now an EHP is coming to the picture. So EHP is a electric motor-driven hydraulic pump. The EHP can be equipped with variable displacement pump, and it is driven with constant speed. And in case of fixed displacement pump, we can operate the motor with an inverter to achieve variable oil flow and pressure. This is just an example. Modern machinery has many work functions where we use EHPs, and EHP will make heavy-duty linear and rotational movements possible. So all these examples need energy. So the future challenge for the machine builders will be how machine can carry that energy that it needs. Is it batteries, supers, fuel cells, or what? We don't know that.
Thanks, Ville. Thanks, Tim. Thanks, Tim. If you could briefly tell me, where does Parker fit in to contribute to carbon zero?
Yeah, great. Thanks for the question. Parker is a global automation company which has been engineering solutions now for well over 100 years. We see the big picture with products and expertise across a range of technologies, allowing us to support both the industrial and mobile sectors. You'd be surprised at the full range of products and the diverse markets which Parker supports. From aerospace to pick and place, Parker has a product. Parker solutions have enabled countless technology leaps over the past century, and meeting the challenge of global climate change is no different. Building on our experience in the mobile sector, we are able to meet this challenge offering solutions including highly efficient permanent magnet AC motors and drives, integrated electro-hydraulic pumps, filtration, cooling, fluid transfer, actuators, optimized control, remote connectivity, and so much more. I will let Ville explain a little more on this.
Thanks, Tim. So over to you, Ville.
Thank you. So when we look at machine, there are specialist companies working with batteries and battery management systems. And that is probably the only area on the machine where Parker does not provide the solution. However, we can deliver drives, electric permanent magnet motors, hydraulic pumps, the valves, accumulators, cylinders, and hydraulic motors. We can also deliver the hoses and connector products, and also the very important thermal management components. So electrical controls, sensors, and IoT solutions for the system remote monitoring will allow us at Parker to provide fully optimized solutions. So I would like to say that we would like to consider Parker as one-stop shop for customers.
Great. Thanks, Ville. Thanks, Tim. If we simply swap out the ICE for an electrically powered solution, what does this involve?
Yeah, thanks for the question. It would be possible to size a direct electrically powered replacement for an internal combustion engine driven system. But this is a highly inefficient way to proceed. What we need from customers is detailed information on actual power requirements. Talking about the work functions, we need detailed plots of flow against pressure for typical duty cycles. We can take this information and produce mathematical models to calculate the most efficient systems. And the more efficient the system, the greater the operating time, or the smaller the batteries required, for example. Efficiency runs right through the process, from the work cycles to the parts used. Small percentage gains can have a dramatic effect on savings for both the original equipment manufacturer and the end user. Parker offer online efficiency calculators to show some of the benefits to switching to the most efficient motor drive solutions. So no, it's not a case of directly sizing a replacement system based on the previous ICE-driven solution. And thermal management is another key consideration. I'll let Ville explain more about this.
Thanks, Tim. So over to you, Ville, if you could add on what Tim said.
Okay. As Tim mentioned, the engine swap out is not a simple task. And the second difficult question is the thermal management on the machine. So the new technology will also require cooling and also heating. So when we talk about full electric and battery powered machines, the batteries have their own preferred temperature range. You can say 20, 30 degrees centigrade. Drives and motors also have their own range, up to, let's say, 60 degrees centigrade. And if we still talk about hybrids, and then the diesel will have the third temperature range, closer to 100 degrees centigrade. These different temperature levels can prove a challenge to temperature control. And also in colder climates, the heating, or should we say warm up of the system to operation temperature, is very important requirement before starting we work. So continuous and high power applications, we have specified demand on the system design which the ICE powered machine may have been able to fulfill. But the machine in the future with electric components may need more than one machine size to fulfill the different operation conditions, say light, medium, and heavy duty. In this case, it may be that one size solution does not fit in all applications.
Does an increase in control and optimization of systems produce real benefits for efficiency like energy recovery? What do you think?
Yeah, okay. So, I mean, there's been a real step change in the level of control available for mobile systems. And from my perspective, the willingness of mobile OEMs to adapt and adopt new technology solutions in recent years. This applies both to embracing new power sources such as electrification and the increased levels of control and safety, which are partly driven by industrial standards. But not only that, I mean, off-road machinery needs to embrace the age of the smartphone, apps, and IoT, just like everywhere else. There is an expectation from the manufacturer down to the end user. Thinking more specifically about the e-power takeoffs, our permanent magnet AC motors and drive systems can be tuned to fully optimize the running of hydraulic pumps or direct transmissions. This increases performance, reduces wasted energy and unnecessary running noise, and again, increases overall efficiency. We are able to optimize system performance and via telematics connect remotely to monitor and to tune systems. This also brings the benefits of things like asset management and predictive maintenance. In the near future, software parameters will replace screwdrivers with parameter tuning carried out remotely. Ville will explain more.
Thanks, Tim. Ville, if you could add on something what Tim said.
Yeah, so the electrified machines, they can be fully optimized. And in many applications, energy recovery is also possible. Energy recovery must be designed into the system, into the machine. Furthermore, many applications will simply consume energy and offer no opportunity for energy recovery. Today's electric and hybrid cars can recover braking energy and store it into the batteries. In similar way, working machines can store braking energy, and there is already solutions in the field that can offer this. Mining trucks is a typical example where the payload is transported uphill using energy, and it's, however, during the downhill phase that the traction energy can be recovered. Cranes and forklifts can also regenerate when lowering the loads. And this energy recovery from the work function is done by utilizing the EHPs. Excavators can also recover energy from swing or slew function. So all of these applications will need a control system that can optimize the work cycle and components that can that enable the energy recovery. Energy recovery will never will deliver savings and can also improve performance and also the operator experience.
How is safety applied to electrified vehicles, and how will this affect autonomous vehicles, Tim?
Yeah, of course, safety is extremely important, and safety standards are already there. ISO 26262 in road vehicles, for example, and in our world, the more familiar EN 13849 machinery directive governing off-road vehicles. And there are many, many more. Electrification simply moves the power of specific safety-related functions, such as the transmission, away from the ICE to electronic drives and motors. In vehicles, the machine management system relies on robust safety measures, including redundancy, tri-state controllers with internal polling, and within the closed-loop motor drive systems, ensuring fail-safe responses are maintained. This is very much an application-related question and needs to be considered case by case, the safety measures and controllers that are required. The levels of safety are, of course, significantly increased when we begin to look at the implication of things like steer-by-wire, where we remove the mechanical linkage, and how we manage the vehicle. Ultimately, we are, of course, looking towards autonomous vehicles. And I'll let Ville explain a little more about that.
Thanks, Tim. Ville, if you could add on what Tim said.
So electrifying machine functions may enable the autonomous functions in the future. Like an autopilot in airplanes today, planes can take off, they can fly and land without any human touching controls. However, the planes still have pilots on board. But the synergies were already there. When the driver is present, we can have automated or assisted functions that the driver activates when necessary. For example, in many agriculture applications, the driver can activate the autopilot, and with the GPS receiver and using a detailed maps in the control system, the tractor is guided along the optimal path. Now the driver does not have to concentrate on the steering function and instead focus on other work functions. In marine applications, we have already seen some prototypes where ships will cruise without any crew on board. So autonomous vehicles are coming, and electrification combined with full telematics paves the way. For sure, in the future, some off-road machines will benefit from results of the marine and aviation experiences.
How does Parker go about bringing the key technologies together? If you could elaborate on this.
Yeah, okay, that's the key point. I'm just going to take this one myself, so Ville can put his feet up. Parker recognized the challenges in developing electrification solutions for the mobile sector, and in particular, the off-road machinery, where Parker have traditionally been a large stakeholder. Product development of permanent magnet AC motor technology and inverter drive functionality needed to be developed in tandem with the safety standards we've discussed for integrated system solutions. Parker recognized that the key to developing electrification system solutions lay in bringing together expertise from different technology groups. Shared knowledge, expertise, and experience are the key. MTC, Parker's Motion Technology Center, is a joint endeavor between aerospace and the motor systems groups within Parker. The key engineering expertise from both groups creates a perfect technology transfer opportunity. The enhanced capabilities of MTC allow Parker to develop electrification solutions to meet the technical and safety levels demanded. Our colleague, Dave Blood, will present a vision of how Parker's MTC is working to provide the off-road machinery system solutions for today and for tomorrow. Thank you.